Let's look at solving some logarithm equations. There are three places the variable can be. One place is on the right-hand side, and we've already solved equations like this when we learned how to simplify logarithms. So here the variable is on the right, and we have log base 6 of 216 equals x. We'll change this to an exponential equation and get 6 to the x power equals 216, because there's our base, there's our exponent, and here's what we get when we take our base to our exponent. We'll solve for the variable. You might be able to do this in your head, but if not, realize that 216 is 6 to the third power, and now 6 to one power equals 6 to another power. These exponents must be the same, so x equals 3. And we will leave the x here because there was an x at the start. This is an equation, and so we will say that x equals 3. The variable may be just before the equal sign, and often these are the easiest kinds to solve, as you'll see. So here we have log base 2 of x equals 5. We're going to keep following this same plan of changing this logarithm equation to an exponential equation. So here's our base, here's our exponent, and that's what they're going to equal when we take the base to the exponent. So 2 to the fifth power equals x. Now we'll solve for the variable, and it's already all by itself on the right-hand side. We just have to take 2 to the fifth power. That's 32. So x equals 32. Now, you try this one. Log base 81 of x equals 1/2. Pause the video and follow those steps and find out what x is. X equals 9. Remember that when you have an exponent of 1/2, that's the same thing as a square root. So 81 to the 1/2 power is the square root of 81. That's 9. The variable may also be in the base. That's our third spot. So here we have log base x of 243 equals 5. Same game plan. We're going to change this to an exponential equation. Here's our base, there's our exponent, and that's what it's going to equal when we take the base to the exponent. So x to the fifth power equals 243. Now we're going to have to use either a root or a reciprocal power. Since this is an integer, it's x to the fifth power, I'm going to take a fifth root on both sides. That's going to be, the fifth root of x to the fifth will be x, that's why we're doing it. And then the fifth root of 243, and that is 3. 3 to the fifth power is 243. 3 times 3 is 9, times 3 is 27, times 3 is 81, times 3 is 243. You try this one. Pause the video and solve for x when we have log base x of 125 equals 3. And you get that x equals 5. You, in exponential form, get x to the third power equals 125. Take the cube root of both sides, and the cube root of 125 is 5. Check this one out. Log base x of 1,000 equals 3/4. We'll just keep following the same strategy. Change it to an exponential equation. Here's our base, here's our exponent, and that's what it's going to equal when we take the base to the exponent. So x to the 3/4 power equals 1,000. Now to solve for the variable, we're going to have to use either a root or a reciprocal power. Since we have a fraction for an exponent, I'm going to suggest using the reciprocal power. So the reciprocal of 3/4 is 4/3. And we'll take both sides to the 4/3 power. That means this left-hand side is just going to become x, because 3/4 times 4/3 is 1. 12/12 is 1. That's why we picked it. Then we'll have to figure out what 1,000 to the 4/3 power is. Well, that's like 1,000 to the 1/3 power to the 4th power. 1/3 times 4 is 4/3. And 1,000 is a perfect cube. Remember, the fraction exponent 1/3 means to take a cube root. And the cube root of 1,000 is 10. And then we figure out 10 to the 4th power. Well, that's a 1 with 4 zeros on it. X is 10,000. And that would be what would happen. Log base of 10,000 of 1,000 equals 3/4. That means 10,000 to the 3/4 power equals 1,000.